everyone, it's Alyssa and welcome to You Can Learn Math.
Today we're talking about the length of an arc in a circle. Now, when we say an arc in a circle, this is what we're talking about. If I have, I have a circle and I pick 2 points anywhere on the circle, and then I'm highlighting the area of the circle, the part of the circle that's between those 2 points. That's an arc. It can go either direction. This also could be an arc. And these points again can be anywhere on the circle. Now you will be asked at some point to find the length of an arc in a circle. Now, if you watched my previous video about the area of a sector of a circle, some of the principles I'm going to discuss are exactly the same. This is all about proportions. What portion of the circle does this arc represent? So if you are looking for the area of the sector of a circle, like when you're trying to say, what is this area? That's a separate video. Link is down below. All right, so first things first, I want to make sure we're all on the same page and that we all know how to find the circumference of a circle. The formula for that is circumference equals 2 times pi times r. And some teachers in math books will also tell you pi times diameter. Those are the same things because the radius, if I have one radius and I have 2 radii, that's the same as a diameter. So 2 times the radius, same as diameter. Okay. So that's just a quick reminder. If you would like more explanation about this, a separate video, link down below. All right, so circumference is 2 times pi times r. Another circle fact that we need to know to do this problem is how many degrees are in a circle. So if I had a straight, if I had a straight line, and then I started and I went all the way around, how many degrees did I go through? Let's turn that ink to shape feature off. That's not being helpful anymore. All right. So if I had, how many degrees would that be? That would be 360 degrees. Now these are our 2 facts we're going to use to solve these problems. That the circumference of a circle is 2 times pi times r, and it's 360 degrees to get all the way around. All right, so before we get into the exact way we're going to do this, let's talk about the principle that's at work. Let's say I had a fence, a little standard sort of wooden picket fence. And I told you that to put this fence up, that this fence is 10 feet long. And then you say, oh, well, I already have some fence. I need 10 feet of fence, but I already have some fence, so I only need half that amount. I need half. I need like from here on. How long is the fence that I need? Like, I already have this bit. I already have that. I don't need that. I already have it. But I do need a little more fence. I need half of the length. You go, oh, well, the whole thing is 10 feet long and you have half of it or you need half of it. Same difference in this case because half plus a half is 1. So I say, oh, so how much do I need? I need half of 10 feet. Half times 10 is 5. So I need 5 feet of fence. That's how long the fencing needs to be. And no matter what this fraction is, we would do this math the same way. Like let's say I said, oh, I bought only 2/3 of it. I need 1/3 of this fence. I need to buy this. How much do I need to buy? Then I would say, oh, I need 1/3 of the 10 feet. A third, I know numbers. 1/3 of the 10-foot length. What's 1/3 times 10? It's 3 1/3. So I need 3 1/3 feet of fence. So we have the full length of the fence. We multiply it by the fraction, the portion we're talking about, and then we get our answer for the length of the fence that we're talking about. This is the principle we're using. That's it. That's the principle. In this case, however, we would view the fence as a starting here and it's going all the way around, like we are fencing in this circle. So let's say I told you that this circle has a radius of 8. We'll say it's 8 centimeters. Then what is its circumference? How much fence, how long would the fence be to go around this circle? So I start by using my circumference equals 2 times pi times the radius. And I know my radius. My radius is 8. And then I can multiply these two numbers together, 2 times 8, to be 16. So 16 times pi centimeters. And I can just leave it like that. This is called leaving it in terms of pi. I can also multiply it in a calculator and get an approximate length for that. But either way is fine. In fact, I mentioned this at the end, but I'm going to say it right now also. Check with your teacher how she wants you to put your final answer. If they say in terms of pi, it's going to look like this. If they say they want the actual rounded number, or they specify we want you to use 3.14, then please do that. And I am going to mention that again at the end because it's important. So if I did a rounded number using my calculator, it would say the circumference is 50 point, I'm going to round to 227 centimeters. That's how long a piece of fence would be if it went around this circle, 50.27 centimeters. Right, so there's my starting point. Now, what if I said, I just want to know what the length of one section of this is? I'm going to zoom in a bit on this circle and kind of recenter it here so we can really get close. Okay, so let's say that I did up like this. And then I told you this angle right here was, let's say it's 80 degrees. Did that with a mouse. I'm weirdly impressed with myself writing that 80 with a mouse. So 80 degrees, and they want to know how long is this arc, this portion of the circumference. Well, previously when we looked over here, zoom back out, when we looked over here, we said, oh, it's half of the fence, or it's a third of the fence. How can we figure out what 80 degrees is, or what fraction of the whole circle this arc is? Well, we look at those degrees. So here it's 80 degrees out of, here's our fact coming back in, out of a total of 360 degrees. So it's 80 out of 360. That's our fraction. That's what we're going to multiply by the entire length, the entire circumference of this circle. Now, a couple of notes on this. Just setting this up, this is the same process every time. You're going to take the angle of the arc. When you have your 2 points of the arc, you go back to the center of the circle and you have that angle. That's the angle you want. You take the angle, the central angle that's connected to that arc, you put it over 360, always over 360 when you're talking about a full circle, and you're going to multiply by the circumference, which is 2 times pi times r, and we already did it in this case. We said it was 16 pi. And I'm going to leave it in terms of pi right here because it's going to make our answer at the end more accurate. So, okay, so that's always going to be the setup. And if you want to use it, if you want to look at like a little formula, it's going to be the central angle of the arc over 360 times 2 pi r. That's what you're going to do. That's where all of this where all these mathematical principles come together. This is the formula that it creates, and that's what you're seeing right down here. Okay. Now, before you actually do the math of, zoom out a little bit here, of 80 over 360 times 16 pi, it's always a good idea, if at all possible, to simplify the fractions, to simplify things. So I'm going to scoot down a little bit here, and I'm going to rewrite this 80 times 360 times 16 pi. Now, when I'm multiplying a fraction times something that is not a fraction, that is a whole number, or just a sort of plain number, you're always going to put it over 1. Okay, now I want to see if there's anything I can cancel, if there are factors in the top and bottom that can come out. And there's no right or wrong way to do this. You just want to get things as simple as possible. So here's an example of a way I might do this. I might look over here. I might start going 80 over 360 and go, those both end in 0. They're both divisible by 10. So I'm going to divide both of those by 10. 80 divided by 10 becomes 8. And 360 divided by 10 is 36. Okay. All right, that's helpful. Well, can I go a little better? Let's see. What's the number that goes into 8 and 36? It's like 2. Is there anything bigger than that? 4. 4 goes into both of them. 4 goes into 8 2 times, and 4 goes into 36 9 times. So, okay, so now I have 2 times 16 times pi on top, and I have 9 times 1 on the bottom. Can I simplify any further? No, I can't, because the only things that go into 9 are 3 times 3 and 1 times 9. And 1, 3, and 9, none of those go into 2 or 16. So, no, I can't simplify any further, but that's helped a lot. So now I'm going to multiply on top. 2 times 16 times pi. 2 times 16 is 32. Pi just stays there. And on the bottom, I have my 9 times 1. That's 9. And that's my answer. 32 times pi over 9 centimeters. I know that looks a little awkward, but that is the most accurate version of this. We're not rounding. We're not doing anything. Again, this is called leaving it in terms of pi. If you see on the worksheet, test, etc., or if your teacher says, leave it in terms of pi, this is what they want. If you see the use 3.14 for pi, that's what they want you to do. They want you to type in 32 times 3.14 and then divide by 9 in your calculator. If it says round to the nearest hundredth, they want you to just use the pi button on your calculator.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.